The movie?
Oh my god, guys. You mean the science movie, perhaps?
What? I told you this was the wrong stage.
Hello, this is Mr. Crouch's 7th grade science class video project. What is matter? That's a difficult question to answer, but we can describe matter by its physical and chemical properties. All matter has the physical properties of mass, weight, volume, and density, the 3 general properties of matter.
Mass, the amount of matter in an object. Using a balloon, we can show that everything, including air, has mass. As you can see, the mass of the balloon was greater when it was blown up than it wasn't blown up. Thus, the air inside the balloon has mass.
Wait, the pull of gravity on an object with mass.
Unlike mass, weight can change. As you can see, this astronaut is almost weightless. This is because the force of gravity pulling on him or her is almost zero. But even though his or her weight has decreased, his or her mass has not changed. Volume, however, is defined as the amount of space an object takes up. By using a tissue jammed into the bottom of a cup, we can show that air has volume. We put the cup in the water, and if you take it out again, you can see that the tissue is still dry. This is because the air has no place to go, so it has to push the water away.
Another general property is density. Density is the mass per unit volume of an object. Bobbing mothballs demonstrates one of the physical properties, density. When you fill water in a cylinder and put 2 mothballs and a pill, the pill in the water makes bubbles. So the mothballs first float, but they become denser by the air bubbles and they sink. When they sink, the bubbles on the mothballs are gone, so they become less dense and go up again. Then, mothballs go up and down continuously.
The oil we used in the demo is denser than the alcohol, but less dense than the water. We first fill the beaker with some alcohol and then we put some droplets of oil in there. But when we add water to the mixture, the densities of the water and alcohol combined become greater than the oil, so the oil hovers in the middle of the water.
Matter can be described as being made up of particles. Solid particles are tightly packed and cannot move. The class is pretending to be solid particles. This ice cube is water in a solid phase. Now the class is pretending to be liquid particles. Liquid particles are freer to move and take up the shape of the container they are in. This is water in its liquid phase. Now the class is pretending to be gas particles. Gas particles are freest to move and take up the available volume. This is water from a liquid to a gas. Another way to demonstrate particle theory is with the simulated hot air balloon. Here are 2 paper bags filled with air. Watch what happens when the air in one of the bags heat up. Hot air is less dense because the particles of air take up more space as they move around faster with the added heat energy. This causes the bag with the hot air to float higher than the bag with the cool air. Here is a small beaker inside a large beaker filled with boiling water. The beaker has been taken off the burner. You can see that the water is being drawn up into a small beaker. This is because when the water boiled, it turned into water vapor, which took up more space than the air that was originally in. Now as it cools, its volume decreases as the particles of water vapor slow down and move closer together. The water then takes up the space left behind. This is also an example of Charles's law.
The water particles are getting heat energy from the stove, so the particles in the bottle change into another phase change, which is gas, and evaporate. This phase change is called evaporation. When the particles evaporate, the gas particles rise until it reaches something cold. When enough water vapor is in the cloud or the glass container, the gas turns into a liquid again. This phase change is called condensation. Now you know how to make rain.
Gas is the phase in which matter has no definite shape and no definite volume. Gas is all around us. Gas is any evaporated liquid. When a liquid evaporates, it becomes a gas. When it condenses, it becomes a liquid. We can demonstrate this in a clear plastic bottle by making a cloud. Some particles from a match will act as a nucleus to help form water droplets inside the bottle. When pressure is added to water droplets in a suspension, the water droplets vaporize. When the pressure is released, the vapor condenses again around the particles of smoke. This is also the reason why clouds form in the atmosphere.
Here you can see plasma, the fourth stage of matter. Plasma is extremely rare on planet Earth, but it's one of the most common phases in which matter is found around the universe. Plasma is quite dangerous to animals because it contains extremely high energy sources. One example of plasma is the sun, and another is fluorescent lighting.
Matter can also be described by its chemical properties. Chemical properties describe how a substance changes into a new substance. One such property is flammability, or the ability to burn. When we burn a match and cover it with a beaker, the fire dies. Like us, a match can only live moments without oxygen.
Some other chemical properties are pH, the amount of acid, and conductivity. Electric lemon demonstrates both these properties. The wires react with the acid and the lemon at different rates. This produces extra electrons around the paperclip, making it negatively charged. When we attach the cable and the copper and one to the paperclip, it creates an electric current that we measure in voltage. This means that both the lemon and the metal wires have the ability to conduct electricity. The amount of electricity produced by the lemon is only 0.5 volts or less than that. But when there are more lemons, there are more electric charges, so it produces more voltage. According to demo, we did it with 3 lemons and got almost 1 volt. So, the more lemons you have, the more electricity you can produce.
Physical change can happen without changing identity or chemical nature of the substance.
Chemical change. When a substance changes into a new substance, chemical changes can also result in physical changes. We can demonstrate this by mixing sulfuric acid with glucose sugar to start a chemical reaction. The acid slowly burns the sugar, turning it into carbon. Notice how the colors change. Notice how the temperature rises. These physical changes are signs of a chemical change.